Let's get set up here. Hello, everybody. Um, Looks like people haven't joined yet. I'll give it a second. Thanks for helping me out, Cindy. There you go. Hello, everybody. We have some people coming in right now, but I'm going to give it until about 2:03 before we get started. All right. Well, we'll get started then. Just to let you guys know, while I'm doing the presentation, I won't have direct eyes on the chat. However, I'll have Eric, who's a coworker of mine, in the chat answering questions if I'm unable to. But without further ado, let's get started. Today, we'll be talking about triaging slow performance in Splunk environments. We'll be covering a lot of broad information today. Um, Odds are we're not going to be able to get into everything under the sun. But if you guys have any questions, concerns, comments about anything we're covering today, feel free to drop it in chat and let us know. Let's get started. First thing I want to cover is who we are. My name, as I said, is Robert Caldwell. I'm a Splunk support analyst here at Presidio. I work on what is called the CX or customer experience team. We provide expertise on demand for our clients. It's considered a phone a friend service for our clients alongside our product Atlas. You can find us on YouTube at Presidio Splunk Solutions, formerly Kinney Group. And we also have a blog at kinneygroup.com/blog, where we write about search commands and Splunk features. Today, we're going to be covering simply indicators of poor Splunk performance. We're going to teach you how to diagnose root causes of that, how to discover and categorize performance issues, and then we'll cover practical steps on how to resolve and prevent these issues, both short and long term. And I want you all to walk away today with actionable knowledge and techniques on how to do this. This is primarily for users who want to get better at dashboarding and searching, whether that's ad hoc or scheduled searching as well. Splunk admins who are responsible for knowledge objects and efficient ingestion into their environment. We'll also be talking and touching on things like data models, summary indexes, and the like, and lookups that we can use to help reduce performance issues in our environment. And lastly, server admins. A small portion of what we'll be covering today will talk about resource usage, specifically on-prem resource usage. And if you're a server admin responsible for controlling the servers that Splunk resides on, along with their CPU, RAM, and disk space, this could be relevant to help you out as well. And lastly, before we get started, I just wanted to cover some questions I wanted you guys to think about while we're going through all this. And you should come away being able to answer, what does an efficient versus inefficient search look like? How is your indexing workload? That's specifically that meaning, how is it looking? How is it, what exactly does it look like? Do you know what your indexing workload is? How much processing power is being used to index or each source type? And finally, how much resource usage is your on-prem servers utilizing? Are they utilizing 30% every day, 80% every day in CPU? Um, are you having hardware issues? Are there malfunctions? We'll cover that today. As well as questions to consider asking us by the end of this, because this is definitely going to have to be a one-size-fits-all lunch and learn. We're going to have to cover a lot of general topics, but Feel free to ask us. How can we help you address your specific performance challenges in your Splunk environment? Are you experiencing any specific performance pain points that weren't covered? And are there some points that were brought up that were unclear or you think should be talked about in greater depth? We're always looking to improve and iterate these lunch and learns as we do them, and we're more than happy to take any feedback you have for us. And lastly, we'll get started. Today, we're going to be talking about how to recognize performance problems, tools, and how to categorize those problems. We'll cover the actual root causes of those performance issues by each category. We'll then also slide into demos during that point so I can show you specifically what in those categories looks like for both good and bad issues you might find and where to find that. We'll cover prevention and best practices, specifically how to prevent these issues down the line, both next week and next year. And lastly, we'll wrap up with some Q&A. So, first thing is recognizing performance problems. And this is going to come in two ways: user experience complaints and system indicators. User experience complaints is going to come into the form of ad hoc, which is ad hoc searches and dashboards. Searches are much slower than before, or hanging up before running could be an indicator, as well as dashboards failing to load. Your users might reach out that they can't reliably search their data. Scheduled searches are skipping or failing. Maybe alerts aren't firing on time. Maybe reporting misscheduled runs for reports, or maybe the scheduler queue is backed up and searches aren't running when they're supposed to. And maybe there's a disconnect between the data being generated and when it's being searched. Maybe indexing is taking longer. It means a larger delay in the data appearing in Splunk, and important data could be missing by the time important searches are ran. Secondly, we have system indicators. This could be from forwarders unable to forward correctly. Maybe their queues are growing. Maybe the data is backed up from being ingested. That could mean that there could be connection errors to indexers from those forwarders. Maybe it means that data is being dropped. With the indexing rate, maybe data ingestion throughput is declining, which would be a major issue. Maybe index queues are building up and you're having hot bucket management issues. Is data arriving with some lag behind it? Which, like I said before, it could display stale information, not relevant. Even though the data might be being generated, maybe it's not appearing in Splunk immediately. And lastly, there could be excessive hardware metrics. So is your CPU utilization constantly above 80%? Is memory usage approaching its limits? Are you having I/O disk bottlenecks? And is your network bandwidth being saturated by all this data being flushed into Splunk? So we'll go over how to categorize this as well as tools to do it with. And then we'll get into actually what these issues are and where they come from. To start off, our first category is going to be searching. Searching is going to be 80%, odds are 80% of the issues you will run into. That could be coming from them consuming an excessive amount of resources. Maybe they're skipping or failing. And maybe there's inefficient SPL patterns in the midst of these searches, whether that be on scheduled searches or dashboards. The second one's going to be data. This will be how is your data being ingested? Is it being ingested properly? It'll also be your license usage. License usage is how Splunk scales the amount of data you expect to ingest, and you want to make sure that you're not going over that license usage. And lastly, index metrics. So, are your indexers and indexees properly getting the data they need? Lastly, we'll talk about hardware. This could be physical memory, it could be CPU, it could be disk. Basically, anything that helps the server run is where this last category will be. And the first tool to help out with this will be Monitoring Console. The Monitoring Console will be your primary place where you will get an at-a-glance overview of dashboards or of your data with dashboards and charts. It will provide everything from search information, indexing information, and resource information, as well as a lot of other stuff and a lot of different ways to break it down. However, it is still very high level. it is still very much a, you know, one size fits all. It's a very generic way to do stuff. And thankfully, Splunk provides it out of the box as a great first step to monitoring these issues. Secondly, we have third party apps. These can provide more unique insights, specifically if they're tailored for specific types of servers or data coming in. Uh, they often use specialized tools and searches to do so. Some of them are premium, some of them are free. Um, some of those include IS4S or Splunk Insights, Atlas, which is our premium app that we provide, as well as migration assessment. If you're going to be migrating from on prem to the cloud, this is a common app we see people use to make sure that their environment is up to snuff before they do that. Lastly, we'll be using SPL, which is the most granular, but also the most complicated method. But if you're very good at using Splunk and very savvy, it could be very helpful. You can get deeper insights into your data. You can use things like monitoring console to get a springboard into a specific type of data you're wanting to look at, and then drill down into the SPL to find specifically what you want to find and investigate those issues. Now we'll slide into the pseudo demo portion of it, which is where we're just going to talk about, frankly, a lot of information. The first set of issues we're going to be covering are going to be over search performance. So this is going to be our first category. And I just have a couple examples up here, and I'm just going to show one example. That way we can just keep moving. And this is going to be a mixture of me showing you good searches versus bad searches, and where you can look both on-prem and in the cloud, because monitoring console and both of those are different, to find these issues. To start off with, inefficient search practices. Maybe it's a lack of filtering. Maybe you're using real time, excessive wildcarding. In that case, obviously, the ways to prevent that would be to filter early, not use real time and use the smallest window possible. Use fast or smart mode instead of verbose. And we'll cover right into that right now. So here I have, let me zoom in for you guys. Here I have a search that is very much expensive, and I've already ran it for the results, and I'll go ahead and run it again. And you'll see that for the sake of this, because of the demo data, it is going over all time. And that's just to show the wide range of difference. And so if we run this search, you'll see that mainly because of things like using recs, using stats, using event stats, those are pretty heavy searches because of what they do. And often we want to prevent using things like that if we can, or at least if we're going to use them, minimize the amount we're going to use them. And as you can see now, it's about 80% done. And we can check to see how long it ran for. And if we look, I went to job, inspect job, and it will pull up a new tab. And we can see that it took 22.6 seconds to run, which isn't great. I mean, that's not terrible, but as you can imagine, if this is our status quo for our environment and we're running a bunch of searches at this similar level, it's not going to be good. So instead, we can see what it'd look like with just a simple top command and how short that would be. And I know that this is a pretty extreme example, but this is just to show how your choices between the SPL you use can make a massive difference. And if we go to inspect job again, you'll see that it only took 4 seconds. And we also, and because this we used top mode and we ran it in fast mode because verbose wasn't necessary. And this is where you can see fast, smart, and verbose. Odds are, specifically for any searches you'll be running a lot, especially ad hoc, it's smart to use fast mode if you know exactly the fields you want to search. Smart mode, oftentimes, if you are just doing a cursory search, and only use verbose mode if you really have to, because it is going to pull up all the events and all the fields and all the values, and it's going to present them to you, which is very nice if you need that. Next thing as well is we're going to talk about how the monitoring console works. I'm here in our Splunk cloud environment, and as you can see here, we're under license usage and workload. And for those of you unaware, Splunk Cloud works a little bit differently with how it measures your license. It could either be through SVCs or ingestion. In this case, ours, we don't have an SVC license on ours, but that's how it basically compensates for your hardware usage. So instead of looking for resource usage, you're going to be looking at SVC usage, if that is how your license is based. And if we see right here, we have a bunch of KPIs about overall usage, search, indexing, and it breaks it up for us. And we can even come down here and see under search workload, by estimated SVCs in the search type, we can see that a lot of our searches are scheduled searches, and that's where a lot of our SVCs are coming from. And you can use this to make sure that you are staying within your license and ensuring that you are following best practice to do so. And as well as, I also just pulled up a dashboard I whipped up, and this is generally just another way you can monitor it as well. If you find that monitoring console isn't specifically getting you what you like, you can also make custom dashboards to do so. And in this case, I actually set off some skip searches for this a while ago. But you can see that right here, we have a unique number of skip searches by day. And so recently I set off a bunch of skip searches. That way it would actually stimulate the graph. And we come down here, total number of skip searches. This would be another way to do so. And monitoring console does help provide this, but I'm just showing you another way that you could go about doing this. We also have top skipping searches. So this is my top 10. A lot of them are accelerated data models, which I turned on for the sake of making a bunch of skip searches. And these are just a lot of different ways that you can monitor this stuff. And as I said, often searching is going to be 80% of your issue with poor performance. And you'll often see this where the searches lie, which is on search head clusters, maybe even on heavy forwarders, or in the cloud. In the cloud, that doesn't really matter so much, but it's still something to watch. As well as, we also have dashboards and visualizations. Dashboards and visualizations, especially very big, elaborate dashboards, ones that don't use the same base search, that don't chain off the same data, and all are effectively running an entirely different search side by side, can cause issues, especially if you have a lot of panels. The best way to prevent that is to split up your dashboards. If the data is not relevant all on one page, then split it up to be on different pages. Use post-processing searches, which means have a base search in your dashboard and then chain searches off that. That way you're only using that original cursory search and you're just pulling that data and sourcing it out to other panels. Lastly, scheduled search issues, which is a massive one we've seen, especially if you have enterprise security and you're running a lot of lookups, a lot of data models, anything with SIM compliance, you're going to find that you have a lot of scheduled searches come out of the box from that. And that's a common thing with a lot of out-of-the-box apps. Most apps you'll have might have scheduled searches that come out of the box enabled. That could wreck your environment if you're not careful about what they're doing and you're not cognizant of them. If you want to see what searches are running with a specific app, all you simply have to do is go to Settings, Searches, Reports, and Alerts. And then from here, you can actually look by app. You can also look by each user. So in this case, I can look in the search and reporting app and see a lot of different searches I've had going on. And from here, we can also edit, we can disable them, we can turn them back on, and we can monitor this and make sure that it's not hurting our environment, especially if we don't need it. Next, we'll cover data. This is mainly going to be accelerating and summarizing your data, as well as getting it in the first place. So we're going to break it up into those two categories. The first one, I'm actually going to cover the bottom point, which is data ingestion problems, because that's chronologically the first one that's going to happen. Edward has a question here that says, can you only see the scheduled searches? In this environment, yes, these are only reports and alerts. So ad hoc searches, the best way to get that would be through, I believe Monitoring Console actually does have a panel, as well as there are ways to get ad hoc searches, often through the metadata of Splunk. I'll keep in mind, I'll try to think on it while I'm going through this, the best way to get those ad hoc searches for you. And hopefully, if I can think of it by the end of this, I'll show you how to. Um, but good question though. So next we're going to cover data ingestion. Like I said, chronologically, it's going to happen. It's going to be when your data comes in first and how it's going to process all that. Maybe you're ingesting data you don't need. Maybe you're ingesting the data poorly. Maybe you're using props and transforms and you're parsing your data in ways that are unnecessary. And possibly you're storing it all in a network storage center, which we don't recommend. We recommend storing it locally wherever the indexer is at, because that means that if your search head has to contact the indexer to find that data, then that indexer has to pull that data out of another area to do so. And it's just wholly inefficient. So we recommend reduce the ingestion of unnecessary data. That will also help with your resource usage as well. You can use smaller and faster drives for hot and warm buckets and use bigger, slower disks that store more space for cold and frozen data if you freeze your data. And then ensure proper bucket distribution if you have an index cluster. The best way to do that is that you'll have a cluster manager if you have an index cluster, and that will hold all the data, which will show your replication and search factor, which is effectively the number of buckets it is holding onto for you to search and the number of ones it's replicating. That way it's not losing that data in case, let's say, one server was to go offline or get bricked. And so to cover that, we'll slide back into Splunk Cloud. And I want to show you indexing workload. And you can see that this is kind of common to see that there's a lot of touch and go with this. And although it's relatively at the same level, it's kind of spreading itself out properly. And it's covering all that data at different times because it's got to process it in chunks. And it'll look very different on-prem. Oh, this is actually also on cloud. This is actually your searchable storage data. So first we went to workload. Now we're at the DDAS, which is effectively just your searchable storage space within Splunk Cloud. Here is a very handy way to see how much storage space you're using, ensuring that you're not going over your licensed limit of storage space, as well as across the board, how much data is in each of your indexes. We have a lot of data in our last chance index because we don't ingest a lot, but we do hold a lot in our last chance index for archival purposes. And here on-prem, oops, let me sign back in real quick. Here on-prem, this is our indexing performance. So if we go here to indexing, to performance, and then to instance, if you have a monitoring console, this might look a little bit different and it will show a lot of hosts. If you have a distributed environment, you should really have a monitoring console if you have the ability to apply one. It is very handy to make sure that everything in your environment is running as it should, all from one place. This is your data pipeline. So if you run into specific issues, and I strongly recommend looking at the documentation if a fill ratio starts filling up, because that can get pretty technical. But this is the pipeline it goes through to write your data within Splunk. And these fill ratios ideally will all be at 0, which means they're not getting filled up. They might go up to maybe 1 to 10% on a very data heavy like day or hour, but overall they should be generally near 0. If they're getting up to 50, 80, 100%, then you might be having issues. Down here as well, we can see the indexing rate per source type. You can also split it up per host, index, source, and we can ensure that, or at least analyze that our data is coming in the proper areas. As you can see here, it's all coming in at a very consistent rate, which is good. Especially you can look at, say, by index. If we look at it by index, and maybe let's say value introspection. If value introspection is costing us a lot of data storage space, we might want to look into specific source types within value introspection. And maybe those source types aren't being used or searched by our users as much as they should be. So maybe we want to stop ingesting those. Saves us storage space, saves us resource usage, and overall saves us the grief of having to deal with it. Acceleration and summarization. This gets a bit more technical for you admins out there. This is all about shortening the searches we have to run. This is particularly so for enterprise security, although it's not foreign to any part of using Splunk. Um, this is primarily using data model acceleration and index summarization. And what that is that Splunk in the background will be running micro searches to be constantly updating a series of values or a series of fields, or specifically maybe a summary index. And these are indexes or data models that are basically ready to go the moment they're searched. They will run a lot faster, they will run a lot smoother, and they will present that data a lot in a very much more cleaner manner, maybe all normalized uh, in the way of data models and SIM compliance. And the importance of that is that if you have a lot of searches hitting the same index or the same type of data or the same data model, it makes sense to have all that data readily apparent. That way, instead of maybe 10, 20-second searches, you have one search that's running in the background every little bit constantly to update this data model. And each of those searches, those 10 searches, only take 2 seconds to search instead. And that saves you a lot of time. Mind you, every time a scheduled search runs, it is taking up one CPU core on your server. And so that means that if you have 8 cores for space and you have 9 searches trying to run at once, one of those searches is not going to run the very moment it's supposed to. It is going to sit there. It is going to wait until one of those searches currently being ran finishes. And over time, those searches might not fully complete before that one waiting search has to skip. It has to basically pass its turn. Splunk has internal, basically guardrails to make sure that those scheduled searches aren't constantly sitting there waiting to be ran. Otherwise, you're just going to get a constant wave of searches lagging behind trying to run. So that's why it's very important to keep all this stuff in mind. Lastly, hardware performance. This is going to be CPU and processing limitations. So, like I said before, each search requires one CPU core. So you have to ensure that you have enough cores and not enough searches that you're going to be constantly overloading it and have more searches than you have cores available. This could be storage performance. Maybe you have inadequate IO capacity. Maybe your servers are out of date in the form of hardware. I mean, if you have servers from 2005, probably going to run into issues trying to ingest the terabytes of data today. If you use a network file system, like I mentioned, where you have all your data stored in one place, that way it can be accessed from across your local or WAN environment, you're going to run into issues as well. Like I said, those indexes are going to be presenting the data to the search heads, and it's going to have to go and fetch that data itself. And the bottleneck there is going to be your network, especially in a WAN environment where maybe it's not local. Lastly, it could be memory and constraints as well. If you have an adequate RAM for searches, that could also cause issues. And as we slide into resources here, you'll see that on resource usage under instance, because we only have one machine here, this is just a dedicated search head, we can see that we have 11 cores, physical and virtual. If you use simultaneous multi-threading or virtualize your cores, it will be equivalent to the virtual amount of cores as well. So if you have 8 cores, but you virtualize it and it multiplies it to 16, then you would have 16 searchable cores for your environment. We also have physical memory. So we have 8,000 megabytes of memory roughly. We're using a Linux operating system. And we can see that over here, we have physical and CPU usage. And this is by megabyte and percentage. So although we have about 8,000 megabytes of RAM to use, we're only using 127. And this is just a snapshot. This is just right now, right here. And we'll get into a timeline here in a second. Same over here. We're only using 0.4% of our CPU. Not a lot. We also have our disk usage. So it shows us where our disk usage is, how much of it we're using, and how much we have allocated for it. So we only have 60 gigabytes allocated for this, and we're only using 12 and a half. So we're doing pretty good. Now we have some line graphs. This is going to be more historical. So over the past 7 days, we can see, and we can split this up by average, median, minimum. I'm more partial to median or 90th percentile, depending on what you're looking for. Median is good for a general overall number of how it's just hitting the metrics. 90th percentile, especially by host, is good for looking for anything like any commonly high running without there being a very big spike. That means that it will basically cut out the top 10% of all your hit metrics across this graph. That way you're not getting any outliers on the high end. So here we have physical memory, we have CPU and disk usage. And you can see here in more of a line chart how our disk usage is being relatively flat alongside our capacity. So we're not going over our capacity limit. And I wanted to also show here CPU usage by instance. And what this is specifically if you're running into hardware issues on-prem, this could be a great way to investigate that. We can see here that we only have this one instance. We have its list of roles, its CPU cores, and how much usage it has. It has a process over time input, which is completely blank because this is just a local instance and it's not running much of anything right now. Same thing, CPU usage by search, which none of my searches are running right now, and historical CPU usage. Those are blank. But that shows you how we can at least on-prem monitor this stuff. For those of you in the cloud, this isn't exactly relevant. Instead, you should watch any SVC usage and ensure that that is within compliance to your license. And that can be from both indexing and searching. Although, like I said, often searching is going to be a better way to reduce hardware usage or hardware resource usage across the board versus indexing. It's often just more demanding, we've seen. Now we'll get to prevention and best practices. Like I said, we had to keep it very high level when going through the root causes. But let's say that you've been able to take this and you found a series of scheduled searches that are running very poorly. Back here, if you have searches that are skipping, and by going to search activity, let's use this one. By monitoring console, by going to search activity, we are going to be able to see ad hoc versus scheduled searches running, and by search activity. Right now, it's not running anything, but we can actually search it by type. And Edward, what you were saying earlier, this would tell you ad hoc searches alongside dashboard as well. Unfortunately, it's not loading anything. I'm sorry about that. I'm just going to roll with it. But we can see search concurrency, so the number of searches running side by side, the number of resources it's using, and most memory consuming searches. This will also include ad hoc searches. Let's say you just take this list and you want to make sure that all these searches are running as like to their best ability. Well, in that case, we can go to searches, reports, and alerts, and we can find each of these searches by searching it, and we can change stuff about it. We can edit it to edit the search itself. This is just a data model search. We can edit the permissions of it. Its schedule, which is very, very critical. If you want to schedule this report, you can have it run on a hourly, daily, weekly, monthly basis, or on a cron schedule. The time range of it is very important as well, but ensure that it is only searching what it needs to. We can run the search ourselves as well. And there are also going to be times when, after a search has ran, if the job has been saved, you can actually see the job here and it will take you to the list of jobs or searches that have been ran. And you can see stuff like the amount of results came back and how long it took to run that search. And so if you have searches that are taking over, say, 5 minutes to run, this would be an important time to look at it and see if there's any ways to optimize it. I just wanted to show you guys how to actually get to these scheduled searches and how you could properly fix them. But now we'll slide into prevention and best practices. So moving forward, now we can take what we've learned and actually apply it. The first thing is, what should you do right now? If you found some bad searches, bad ingestion, your CPUs are going over 80%. What do I do? First step, check out the monitoring console like we've been doing today. You want to use that to identify long running or expensive searches. That could be searches often running over 1 to 2 minutes, or are searching across a long time range, or maybe they're using very heavy search heavy commands like recs, like transaction, like stats. Review your current system resource utilization. This means ensuring that your servers are up to spec, that your resources are being used to their best effect. If you are going to limit your server to, say, 8 CPU cores, then you're only going to be able to run 8 searches at a time. And is that okay? Are you all right with that? And if that suits your needs, that's perfectly fine. But there is a limitation there, and you can only run so many searches at one time and for so long before you begin to really stretch the limit of it. And then also check for any recent changes, especially if you have a lot of users, a lot of power users, a lot of admins. They could be adding apps, they could be adding knowledge objects, they could be writing scheduled searches. And if you're, unsure of what your users are doing, then you should make sure that you have that under control and that they're not writing searches that are overall going to hurt your environment and your production. Let's say in the next 1 day to 2 weeks, you should look at analyzing search patterns. This is over the course of 24 hours or a week. Review scheduled search performance. So this is really getting into the guts of how are my searches doing, especially my mission critical ones. If you use ITSI or ES, odds are you have a lot of searches running in the background, a lot of things that are critical to your job. And you need to ensure that those searches are running at their best capacity and that other searches as well aren't preventing those from being ran. You should examine dashboard complexity. Are there dashboards being built out there that are running massive searches that themselves are taking 2 minutes? And every time you refresh the page, it runs a new search that's going to take 2 minutes. And then assess data ingestion rates. Like I showed you, you can go to the data ingestion page and see that data being brought in. Is all that data relevant to you? Are you searching all that data? Is there any bloat? Are there any issues when you're ingesting that data? And then lastly, maybe from 2 weeks to a quarter from now, you should implement search optimization. This means fixing any searches in your environment or ensuring that your users are following proper procedure to um, optimize their searches in their environment. Adjust system configurations. Splunk has a lot of configurations for you admins on the back end that you are able to use, and as well as any user privileges. So, are you going to limit some users' workloads? Are you going to limit the apps they can read or write to? If they don't have write privileges, they can't save stuff to that app. If they don't have read privileges, they can't access any knowledge objects or that app itself. And that will severely limit their ability to run ad hoc searches or set up scheduled searches in that environment. Plan hardware upgrades. If you're really struggling to get all your searches out there or all your data indexed, and you're really hitting your hardware limits, you either have to expand or reduce. Expand your environment or reduce the number of data you're ingesting and the data you're searching. And finally, establish monitoring and alerting. We often make our own and use Atlas to do so. searches and dashboards to help us with our monitoring and alerting of our environments and the environments we MSP for. Whether that's for ensuring that no searches are getting skipped, that CPU memory and disk aren't going over 80%, and everything else like that. Just a couple extra points here. We recommend proactive monitoring. What this is establish performance baselines. What is the expected performance of your environment? Alerting thresholds, like we mentioned. Maybe set up some scheduled alerting or scheduled searching to pull back reports of if your environment is maybe your CPU baseline for any of your environment is going over 80%. So if your dedicated search head is going over 80%, you'd want to get alerted of that. Make sure that you have capacity and scale as well to handle this. If you're getting a new system in to your environment and you plan on ingesting, let's say, 50 gigabytes of data, is your environment capable of handling that in its current state, or are you going to have to upgrade? Next, we also have regular system maintenance. Regularly check the health of your system, regularly check the searches and the ingestion. Lastly, use some user education. Splunk has a lot of free and paid for classes that can help your users get better at their job. We provide a lot of free webinars on our website and YouTube as well to cover issues like this. Talk about dashboard design guidelines, scheduled search governance, and knowledge object life cycles. So over time, maybe a knowledge object isn't being like maybe it was set up for a specific job, but now that job is no longer required. Maybe it's a data model that's accelerated to run, but now that data is no longer getting searched. You should delete that data model, or at least not accelerate it. That way it's not taking up space. And also, a bigger thing with knowledge object lifecycle is deleting apps you no longer need. We often see that people will just leave apps on their system. And I'm guilty of that myself, where I'll leave apps on my system that I no longer need, and they hurt my environment in the long term. Now, we'll wrap this up with some questions. I have Eric in chat. He's going to drop the reference documentation I have here. What this is a set of just different links to documentation that I have that will greatly help you get started on this that I've relied on. It is mainly having to do with troubleshooting performance with indexing, optimizing searching, and safe search best practices. I'll make sure he's going to drop that. I don't have access to the chat from my end, so I'm going to make sure that he gets that over to you guys. Thank you, Eric. And then while he's posting that in chat, do you guys have any questions as of right now? My email will be on screen in a second. If you guys want to reach out at a later date, I'm happy to talk about this. I'm happy to answer any questions you might have. All right, I'll give you guys all a minute to, if you have any questions you want to submit. But in the meantime, I just want to say thank you all for attending. It means a lot to us. As stated, my name is Robert Caldwell. I'm here as a Splunk support analyst at Presidio as part of the CX team. You can find me at robertcaldwell@presidio.com if you have any questions or any inquiries about the services we provide. And that wraps it up for today. So I hope you all have a great day and thank you for attending.